Hi guys, this is Divyansh Gupta, CAT 1900 Percentiler from IIMpact.mba. For your benefit, I have launched a free course for the CAT 2025 most probable questions. Check the link in description and enroll now for free. Alright folks, so let's start with the Logarithm Surds quiz. Question number 1. A, B, C and D are positive integers and they are satisfying the equations log B base A is equal to 5 by 4, log D base C is equal to 3 by 2 and A minus C is equal to 32. We have to find the value of D minus B. This is given to us and we have to convert it into this using what? The relationships between A and B and C and D are given to us in log. They are positive integers. So this is also something I will make a mental note of. So let's quickly start writing the results. Because the final answer is in terms of absolute differences, I need to get rid of the logs ASAP. So I will get a to the power 5 by 4 is equal to b. And if I raise both sides to the power 4, I'll get a to the power 5 is equal to b to the power 4. Same thing I can do for C and D. C to the power 3 by 2 is equal to D, which means if I square both sides, then C cube is equal to D square. Now to the tricky part. Uh, they are saying that A to the power 5 is equal to B to the power 4. Now both of these are positive integers. Would that mean that B actually will be a number who is itself going to be a perfect fifth power? Otherwise, you will not get both sides as integer. A quick way to think this is a is equal to b to the power 4 by 5 or b to the power 1 by 5 raised to the power 4. Now, if a is an integer, this entire thing will also have to be an integer. Otherwise, it raised to the power 4 will not give you an integer, which means I can write b as p to the power 5. Similar reasoning here, I can write d as k to the power 3. When I substitute this, I will get a to the power 5 is equal to p to the power 20 or a is equal to p to the power 4. Same thing here, I will get c cube is equal to k to the power 6 or c is equal to k square. Make a note that this is again a result you could have arrived, from the first step itself here. The only reason I have first written b and d and then converted it into A and C is because we are being asked D minus B. So I don't want to have that sort of error that I calculate A and C and then, just compute A minus C. Right. Okay. So A is equal to P to the power 4, C is equal to K square. Both P and K have to be positive integers. Now I will plug this into the equation that is given to me, which means P to the power 4 minus K square is equal to 32 or P square plus K into p square minus k is equal to 32. Now this is the equation that I have to work with, right? And because these are integers, p square plus k has to be an integer, p square minus k has to be an integer in such a way that the solution for p square and k, it turns out to be integers itself. So I will now have to factorize 32. I know 32 can be expressed as 1 into 32, 2 into 16, 4 into 8. Uh, do I need to check further? Now, the sum of these two will give me 2p square because k will cancel out. P square plus k plus p square minus k will give me 2p square. Right? One of these factors, the lowest one, is supposed to be p square minus k, and the highest one is supposed to be p square plus k. So 1 into 32, 1 plus 32 is 33. 33 by 2 is not an integer itself. So the under root of that is definitely not going to be an integer. 2 into 16. So 2 plus 16 is going to give me 18. And a value of 18 for 2p square is allowed because p square will come out to be 3. P square will come out to be 9, which means p can be 3. So this is my answer. P is equal to 3. And when I put that, I will get k p square plus k, right? So p square plus k is equal to 16, which means 9 plus k is equal to 16 or k is equal to 7. So I now just have to find the differences. I have to find d minus b. D is k cube, which is 7 cube, minus b. B is given to me as 3 to the power 5. So this is going to be 343 minus 243, which is going to be 100. So the answer for this question is 100. This is a standard approach which should be, internalized. You can do this with hit and trial. You can guess the values based on these relationships, but because as it eventually turns out that the bases are 7 and 3, it makes it tricky for this particular instance, to be able to guess what the values are. All right, moving on. Question number 2. If log 3 base 5, we are given 3 log values and they are in arithmetic progression. So let me quickly write this. Log 3 base 5 plus log 3 to the power x plus 13 by 3 base 5 is going to be 2 times log of 2 to the power x base 5. Now this is a standard representation of an arithmetic progression, right? Sum of the first and third term is equal to twice of the second term. Now I can see that the bases are 5 for each, so I can immediately get rid of my log function. So I will get log of base 5, 3 into 3 to the power x plus 13 by 3 is equal to log of 2 to the power x whole square base 5. Now I can cancel the base. I can remove the base, which would mean, let us cancel this. I will get 3 to the power x plus 1 plus 13 is equal to 2 to the power 2x. Alright, once we have this, we will have to guess the value of x. So we have 3 to the power x plus 1 plus 13 is equal to 4 to the power x. The powers of 4 that I know of, 4, 16, 64, 256. The powers of 3 that I know of are uh, 3, 9, uh, 27, 81, and 243. Obviously, I have written it with a lag of 1 because if x is equal to 1, right, then 3x plus 1 is going to be what? 3 square. So corresponding to 4 on this side, you will get 9 here. So which of these have a difference of 13? I think this one. So x is equal to 4 is going to be your answer, because then you will get 243 plus 13 is equal to 256, which will be 4 to the power 4. So in this question, we have each base as n to the power 1 by n, and we have to find the value of this expression which has 49 terms. 50 minus 2 plus 1, 49 terms. So I can't calculate the values of each individual term, which means that something has to be done. Uh, Either things should cancel out in the sum, or each term turns out to be something which I can add. To find any such pattern, I have to get rid of the log. So I will write the term log n to the power n, base is n to the power 1 by n. This is what each term is, and I can simplify this. I can bring this n here, and I can bring this 1 by n here in denominator. Log n base n, which is 1. So each term is actually, and if I take it above, each term is actually n square. So what they have asked me is find the sum of 2 square plus 3 square plus 4 square till 50 square. If this is my x, I will add 1 on both sides. This is a sum that I know, sum of first n squares. This is going to be what? N into n plus 1 into 2n plus 1 divided by 6. And this minus 1, if I take it this side, will be my value of x. So this will turn out to be 42924. Calculations I will leave for you guys. All right, moving on. Next question. A, B, C are single digit positive integers such that this log relationship is equal to 0, and we have to find the maximum value of A plus B plus C. So let's go sequentially. Log 5, log 4, log 3, log 2 is A to the power B to the power C. This is given to me as 0. So if I cancel this log, I will have to write 5 to the power 0 here, which is going to be 1. Now if I cancel this, I will get log 3 log 2 a to the power b to the power c is equal to 4 to the power 1, which is 4. Now I will take this that side. I'll get log 2 a to the power b to the power c is equal to 3 to the power 4, which is going to be 81. Finally, I will take 2 to the other side. I'll get a to the power b to the power c is equal to 2 to the power 81. Now I can express this. I will have to express it in this format. I can write this as 2 to the power 9 square. From this, it feels like that the answer should be 13, but they have also asked me for a maximum value, which means it should be possible to express this in some other form. Now, to express this in some other form, I have to convert 81 into some other power. So the factors of 81 are what? You can write this as 27 into 3, and 27 itself can be written as 3 to the power 3. So if I go with this methodology, I will have to send this 3 inside with the 2. So this 2 to the power 81 will become 2 cube to the power 27, which is going to be 8 to the power 27, which is 8 to the power 3 to the power 3. The value of a plus b plus c that I will get here is 6 plus 8, that is 14. Can I get some other combination as well? Uh, so let's check for that. Uh, if let's say I write this as 9 into 9, I'll get this as 2 to the power 9 raised to the power 9, right? However, 2 to the power 9 is not going to be a single digit positive integer, which means that, this is the last, this is the highest that I can go for. So your answer will be 14. Moving on. So we are given 25 to the power something is equal to 9 by 256, and we have to find the value of 50x. Now, right off the bat, what are the observations? This is a perfect square, right? So I don't need to be intimidated by this expression. Secondly, 25 is 5 square, the base is 5, and I have a log term with 5 here. So let's separate these terms. I will have 25 to the power log 12 base 5 into 25 to the power 3 log 16 base x is equal to 9 by 256. Now I will rearrange this. I will send 25 inside and bring 12 down. I'll get 12 to the power log 25 base 2, which is going to be, sorry, 25 base 5. Now this log 25 base 5 is going to be 2. So I have 144 into 25 to the power log 16 base x, and we have a 3 also here, is equal to 9 by 256. So I will send this 144 here. Let us see what turns out of this. uh, so at this point, this will cancel out, this will become 16, or this is 16 to the power minus 3. 256 is 16 square, and I have one more 16 here. Now I can see a 16 here and I see a 3 here. So let's now switch the powers. I can say that this is 16 to the power 3 log 25 base x, which is equal to 16 to the power minus 3. So now I can cancel out the base, 16 and 16 gone. This is equal to this. The powers have to be the same. 3 will cancel out. You will get minus 1, or 25. 1 by 25 is equal to x. This is what we will get. So 50x is going to be 2. All right, moving on. The next question. If the distance between the points at which the straight line x is equal to n intersects the curve this and this is 1 by 4, then we have to find the value of n by root 3. The setup is a bit intimidating, distance between the points, but because they have fixed the x value at n, wouldn't, let's say this is graph 1 and this is graph 2, at x is equal to n, wouldn't the distance be the difference of their y coordinates, which is essentially going to be what? Difference between the values these functions take at x equal to n. So what they have given to me in a somewhat clever format is that log of n plus 6 base 9 minus log of n plus 2 base 9 is equal to 1 by 4. So I can now club this with a minus sign. So I can write this as log of n plus 6 by n plus 2 base 9 is equal to 1 by 4, or n plus 6 upon n plus 2 is equal to 9 to the power 1 by 4, which is going to be under root 3, and I have under root 3 here. So it seems to be working out for me. Let me just quickly rearrange this and find the value of n. that I'm looking for. So n plus 6 is going to be n root 3 plus 2 root 3, or n times 1 minus root 3 is going to be 2 root 3 minus 6, or n turns out to be 2 root 3 minus 6 divided by 1 minus root 3. At this point, it might feel like that n by root 3 is not going to come out to be an integer, but it has to because they've asked, which means that this must be divisible by this. So this, if I take 2 root 3 common, I'll get 2 root 3 into 1 minus root 3 divided by 1 minus root 3. So the value of n is equal to 2 root 3. So n by root 3 is going to be equal to 2. So the answer for this question is n is equal to 2. All right, let's move on. Find the sum of first n terms of the sequence log x square plus log x4 by y cube plus log this and this. So clearly, what I have is that there are log terms with the same base getting added. So I will first write this as log of x square into x to the power 4 by y cube into x to the power 6 by y to the power 6 into x to the power 8 by y to the power 9. The general term that you have inside log is what? X to the power 2n divided by y to the power 3 of n minus 1. This is the general term that I have. And that should make sense, right? Now the powers will get added if they are getting multiplied x square. So I will get log of x to the power 2 plus 4 plus 6 plus 8 and so on divided by y to the power 3 plus 6 plus 9 till 3 times n minus 1, and this is still 2 times n. This I figured through the term number. Now after this it's simple. I will write this as what? Log of x to the power 2, 2 I have taken common, 1 plus 2 plus 3 till n divided by y to the power 3 into 1 plus 2 plus 3 till n minus 1. And this expression I can find, this is sum of first n natural numbers and this is sum of first n minus 1 natural numbers. So this is turn out to log of x to the power 2n into n plus 1 by 2 divided by y to the power 3n into n minus 1 by 2. Now this 2 will cancel this 2 and n I can take common as a raised power which I can bring down here. So inside what I'll be left with is x to the power n plus 1. Inside I'll be left with x to the power n plus 1 and y to the power 3 times n minus 1 by 2. So that is the first option. So the answer for this question is going to be A. Alright, moving on. Alright, the value of this is equal to. So now it is very clear that, each is going to be, reducible. So, the numbers that we had memorized, they are going to be helpful now. Let's write this as log of, let me first take this 1 by 2 outside, log of 10 by 4 to the power to the base 0.064, which is 8 into 8. This is 8 into 8 by 1000, which is 8 by 125, which is 2 by 5 whole cube. So this is 2 by 5 whole cube. Let me write this in a neater way. 2 by 5 whole cube, and the insides are actually 2 by 5 raised to the power minus 2, because you have 10 by 4 which is 5 by 2. So actually, yeah, so minus 1. 10 by 4 is 5 by 2, so the invert is 2 by 5. So I can write it like this. The second term is log of 7. It is 7 to the power 1 by 2, and inside you will have 2401, which is going to be 7 into 7 is 49, and 49 into 49 is 2401. So this is 7 to the power 4 plus 1 by 2 times log of 2 to the power 1 by 2, and 8 is 2 cube. So this is my expression. Now each of the log terms have the same base, same as the inside argument. So I can quickly just export the exponents that I have and get to an value which is rid of log. So this will turn out to be 1 by 2 into minus 1, which is coming from here, divided by 3. This 3 will go in the denominator. Plus this 4 will come in the numerator, divided by this 1 by 2 will come in the denominator. Plus this 3 will come in the numerator. You already have a 2 sitting here, and this 1 by 2 will come in the denominator. So if I look at this, I'm getting minus 1 by 6 plus 8 plus 3, because 2 cancel. So this is going to be 11 minus 1 by 6, or 65 by 6, which is option number B. So the answer for question number 8 is going to be B. So this is a very trivial question. You know that the bases, because they are individually different for each other, the bases would be in some iteration going to be same as the inside argument. And this gets asked a lot. Alright, if log 125 base 20 is equal to A and log 32 base 25 is equal to B, and we have to find the value of log 200 base 8. Now, uh, let us first simplify this. So there are a lot of methods for this. A lot of people go with the options. We will solve each and every option and find which expression is coming out to be equal to log 200 base 8. Not a bad approach, but if you are unlucky and the correct answer is the fourth option, then you will have to do this sort of manipulation 4 times, which makes it a lengthier approach. The shorter approach is going to be something like this. Let us observe. This is log of 25 into 8 base 8, which is going to be 1 plus log of 25 base 8. And this log 25 base 8 I can further reduce to 1 plus 2 by 3 log of 5 base 2. This is what my expression is. All that remains for me is to find what log 5 base 2 is going to be. Now, do I not already have this given here? I have a power of 2, I have a power of 5 in the base, so I can just convert the powers and get my value. So this is log of 2 to the power 5 base 5 to the power 2 is equal to B, which means 5 by 2 if I export these powers. Log 2 base 5 is equal to B, which means if I take it downstairs and here, I'll get 1 by log 2 base 5, which is log of 5 base 2 is actually equal to 5 by 2B. So I'll quickly put that here. I'll get 1 plus 2 by 3 into 5 by 2b. And this will give me 3b plus 5 divided by 3b as my answer, which is option number C. So the answer for question number 9 is option number C. So again, you could have hypothetically, calculated the values, and it would have worked. That is fine. You could have calculated what this value is, what this value is, and so on. But I think a little bit of time for observation and simplification can save you a lot of hustle. All right, let's proceed. Log 5 base 2 is equal to A and log 3 base 2 is equal to B. We have to find log 30 base 24 in terms of A and B. So I have log of 30 by log of 24. The reason why I'm separating it into two logs, one in numerator, one in denominator, is because the options itself have numerator and denominator. So it seems like a good call to have. And you have constants getting added to the denominator. So this will become, and let me keep the bases as 2. I can do that. I can pick whatever base I want. I'm picking 2 because the expressions A and B have bases 2. So this will turn out to be 3 into 2 into 5, which is your log 30. The factors of 30 is log 3. Factors of 30 is 3 into 2 into 5. So I can write this as log 3 base 2 plus log 5 base 2 plus log 2 base 2, which is 1, divided by 24 is 8 into 3, that is 2 cube into 3. So I can write this as log of 8 base 2 plus log of 3 base 2. Now log of 8 base 2 is going to be 3. Now log 3 base 2 is given to me as B. Log 5 base 2 is given to me as A. So the numerator is going to be B plus A plus 1, and the denominator is going to be 3 plus log 3 base 2, which is B. So A plus B plus 1 divided by 3 plus B is going to be my answer, which is option number 1. So the answer for question number 10 is going to be option A. Alright, let's move ahead. Z is greater than 1. x is greater than 1, and they satisfy these equations. How many factors does x cube have? So let us again, because they are talking about factors of x cube, it means I have to arrive at a value of x, right? Which means I have to get rid of the log. So the bases are same in the first equation, so I can simply write 2x into 3x. I can write this as log of 2x into 3x base z is equal to 10, and the second argument gives me log of x square base z is equal to 8. So I can write this as 6x square is equal to z to the power 10, and x square is equal to z to the power 8, which means if I reverse substitute, if I substitute x square here, I'll get 6 into z to the power 8 is equal to z to the power 10, or z is equal to under root of 6, which if I put back here, so x is equal to z to the power 4, which means x is equal to root 6 to the power 4, which is going to be 6 square, that is 36. So I now just have to find the number of factors of 36 to the power 3. So 36 is 2 into 3 whole square, and x cube is whole cube of this, which means I have 2 to the power 6 into 3 to the power 6. The number of factors for this is going to be 6 plus 1 into 6 plus 1, that is 49. So the answer for question number 11 is going to be B, 49. All right, let's move ahead. Value of xy. I have an equation here. I see there's only one variable y, and I have an equation here where I have both variables x and y. Now, if I look at the options, I can see that there is a none of these there, and all the options have a different value of y, which means I can first focus on y, get that value, and check, if I can immediately figure out what is going to be an answer. Although the presence of none of these negates that sort of, work. But let's see, let's proceed. I have log 15 by log 8 is equal to log y by log 8. The reason why I'm separating is because I see 8 here and 8 here, and I see 15 here and 15 here. So log y base log 8 into log 15 by log 5, and 15 was under root, so I will put a 1 by 2 outside, 15 to the power 1 by 2. So now I can cancel log 8 cancels, right? Log 15 and log 15 cancels, and I get log y is equal to 2 log 5, which means y is equal to 5 square is equal to 25, which is none of the options. So my answer is actually D. I don't really need to go and find the value of x. So this is a smarter approach. Once you have y, might as well skip finding x, right? All right. So moving on to the next question. This is again a very common template. They sometimes change the year value to what the current year is. So for CAT 2025, this might have a to the power 2025. This is a very common thing. I think the exam setters get a kick out of this. So let's see, what do I have? A to the power 1020, b to the power 1018 is equal to 1 by 9. A to the power 1018 into b to the power 1020 is equal to 9. Now, a couple of observations. Your powers have switched, which means if I multiply these two, I will get same power for A and same power for B, because the power for A will be sum of these two, which is same as sum of these two. So that is observation number one. Observation number two, because again the powers have switched, if I divide, I will get A by B to the power something, which is also something that I can work with. So let's do this. Let us first multiply these two equations. If I multiply these two equations, I'll get A to the power 2038 into b to the power 2038. 2038 is 1018 plus 1020, and similarly this is 1020 plus 1018. This is equal to 1 by 9 into 9, which is 1. So doesn't matter what the power is, I am getting AB is equal to 1. Now if I were to divide these two, I will get A by b whole square, because 1020 minus 1018, which is 2, and for b the power will be minus 2, so I can write it like this, is equal to 1 by 9 whole square, which gives me b is equal to 9a. If I substitute this back, I will get 9a square is equal to 1, or a is equal to 1 by 3, which means b is equal to 3. Now all I have to find is a cube plus b to the power 5. So this is going to be 1 by 3 cube plus 3 to the power 5, or 3 to the power 8 plus 1 divided by 3 cube. So at this point you might feel like calculating these, this is your answer, but again your denominator is 3 cube, so option number A and option number C are out. Your numerator is 3 to the power 8 plus 1. Now this is 729 plus 1, which is 3 to the power 6 plus 1. So this is not the answer. So your answer for question number 13 is going to be option D. All right, moving on. So we have log some expression to infinite terms to the base 16. So we should know that this sequence should sum out to be, this is an infinite sum right here. So let us first focus on this sum. So I have 4 by 3 plus 4 by 15 plus 4 by 35 and so on. Uh, if I write it in the factor format of denominator, I'll get 4 by 3 into 1 plus 4 by 5 into 3 plus 4 by 7 into 5 and so on. Now I get the inspiration that the differences of the two factors that I am writing in the denominator, it is constant equal to 2. So let me modify my numerator as 2, 2, 2. And because it was initially 4, I will put a 2 outside. So this is what I have to work with. Now this one I can write as 1 minus 1 by 3. The second one I can write as 1 by 3 minus 1 by 5. The third one I can write as 1 by 5 minus 1 by 7. And this is a very standard approach. You get the differences of the factors of the denominator as constant and then express the numerator as that. So now this will cancel out with this will cancel out with this, and this cancellation will keep on going till infinity. So the value you are getting is 1 into 2. So the inside term is actually log of 16, 2 to the power 3. So this I can find. 16 is what? 2 to the power 4. So I'll put this 3 here. I'll put this 4 here. I'll be left with log of 2 base 2, which is 1. So your answer will be option number C, 3 by 4. All right, moving on. Question number 15. Uh, Again, I have 12 7 here. I have 12 7 here. I have to find the value of k. The best way would be to just write it in separated format. So log 12 by log 7 is equal to log k by log 7 into this 12 is raised to the power 1 by 3. So I'll bring that out into 1 by 3 into log of 12 divided by log of 11. So log 7 cancel, log 12 cancel, and you get log of k is equal to 3 log 11, which means k is equal to 11 cube, which is 1331. So the answer for question number 15 is 1331. All right, let's move on. Question number 16. Log n base 5 is equal to k, log m base 20 is equal to k, m and n are positive integers. P is the geometric mean of m and n, which means that p is equal to under root of m into n. So what is m? 20 to the power k, and what is n? 5 to the power k. I want the square root of this. This is simply 100 to the power k ka under root, which means this is 10 to the power 2k under root, which is simply 10 to the power k. Now they are asking me for log of p. This is the value of p that I have gotten. So if I take log base 10, I will get log p base 10 is equal to log base 10, 10 to the power k. K I will bring down here. I will get log 10 base 10, which is 1. So log p base 10 is actually equal to k. So the answer for question number 16 will be option B. All right, let's move forward. So we have to find the value of 11 minus root 72 whole under root plus 11 plus root 72 whole under root. So couple of methods for this. First, the easier, more intuitive method is uh, let's figure out what these expressions are going to be. So let's say, let me first convert this into 11 minus 72 is 8 into 9. So that is 3 root 8 or 12, sorry, or 6 root 2. Now I can write 6 root 2 as 2 into 3 root 2. 3 square is 9, root 2 square is 2. 9 plus 2 is equal to 11, which means I can write 11 as 3 square plus root 2 whole square minus 2 into 3 into root 2. What is this? A square plus b square minus 2ab, which means this is going to be 3 minus root 2 whole square. Similarly, the other one is going to be 3 plus root 2 whole square, and this entire thing is getting under rooted and getting added. So this will be 3 minus root 2, and this will be 3 plus root 2, which means Root 2 cancel. 3 plus 3 is going to be 6. 6 is your answer here. Method number 2 would be that I square it. I say 11 minus root 72 to the power 1 by 2 plus 11 plus root 72 to the power 1 by 2 is equal to x. I need to find the x. I will do x square. So x square is going to be 11 minus root 72, that is a square, plus b square plus 2ab, which is going to be under root of a minus b into a plus b, which is going to be 121 minus root 72 square, which is 72. So you will get x square is equal to 22 plus 2 into, this is 121 minus 72 is 28 plus 21, which is 49. So you get x square as 22 plus 2 into 7, which is 36. X square is equal to 36, which means x is equal to 6. Doesn't matter which method strikes you first. This is no brainer. You just assume it 2x and then square it. You will get your answer without any, hiccup. This is sometimes faster. All right, let's proceed to the next question. Product of surd a plus root p into its conjugate, which is going to be a minus root p, is given to me as 33. A into b is given to me as 18. I have to find the value of a. So let's do this. A square minus b is equal to 33 and ab is equal to 18. Now these things are going to be integers because in the way surd is defined, a and b are going to be integers. So I can solve the quadratic that will eventually come out if I substitute b as 18 by a. That will actually make it a cubic. Uh, but because these are integers, I have a possibility of guessing what is the closest perfect square to 33. That is 36. So if I take a square as 36, what will b become 3? So I am getting a as 6 and b as 3. Does it satisfy the other relationship? Yes, it does, which means a is equal to 6 is your answer for question number 18. Moving on. So I have a lot of terms here. I will quickly write these. 1 by root 1 plus root 3 plus 1 by root 2 plus root 4 plus 1 by root 3 plus root 5 and so on till 1 by root 119 plus root 121. Now I need to add this. There are a lot of terms, so I can't individually calculate the values of the terms, which means I need to be able to add these. You have n different fractions getting added. The question hints that it should be something that you can add. Now you can't add fractions to each other if the denominator is not same, which means I should be able to make the denominator same. So how do I do that? I multiply each with the conjugate pair. I will get root 3 minus root 1 upon root 3 square minus 1 square, which is 2, plus root 4 minus root 2 upon root 4 square minus root 2 square, which is 2. The next will be root 5 minus root 3 by 2, and this will keep on going. The last few terms will be root 121 minus root 119 by 2, and before that I will have root of 1 1 3 4 5 till 121, right? So this will be 120 root of 120 minus, this is from root 1 to root 119, so this will be root 118 divided by 2. Now this 3 will cancel with this 3. The coming 4 will cancel with the 4 there. The 5 will cancel with the coming 5 there. So what are the terms that will remain? You will have minus root 1 and minus 2 remaining. Minus 1 minus root 2 whole divided by 2. These terms will remain. Root 119, root 118, they will cancel out. Because you had two terms surplus here of negative, which means I will have two terms surplus here from the positive. So 11 plus root of 120 minus 1 minus root 2 by 2 is going to be my answer. I can now quickly rearrange this. Yeah. So if I take 11 and minus 1 together, I'll get 10 by 2, that is 5. Plus, now root 120 I can write as 4 into 30. 120 is 4 into 30. So I can write this as 2 root 30 minus root 2 divided by 2. And this seems to be the correct option. Let's see. If I further divide with root 2, I'll get this as 1. This as 2 root 15 minus 1 by root 2, which is option number C. So your answer is going to be C for this question. So this part where I figured that the positive terms that will remain will be equal to the negative terms that have remained, it was crucial to, quickly write this expression. All right, folks. So let's start with question number 20. I have root of 5x plus 14 plus root of 5x minus 14 is equal to 6 plus 2 root 2. Now, the method one, which I am sure a lot of people would have done, is to square both sides. But consider this. If I square both sides, I will have x plus some under root x square something something term is equal to, when this thing is squared, it is not going to give you just a rational part. This will also be some integer a plus b root n sort of format. How do I deal with this afterwards? You will say that I'll take x this side, and if you square it again, your x squares will cancel, but would you not end up with a x into root n sort of situation, which is going to be ugly? So this is a method you can follow. You will get your answer because x squares will cancel out. However, it will lead you into a very ugly expression, which might, invite a lot of room for error. Maybe let's look at things a bit differently. Let's call this a. Let's say this is a plus b is equal to 6 plus 2 root 2. Now, if I multiply this with a minus b, so a plus b into a minus b is going to be a square minus b square, which is going to be 5x plus 14 minus 5x minus 14, which is going to be 28, a constant number, which means a minus b is equal to 28 upon a plus b, which is given to me as 6 plus 2 root 2. Now let me further try and simplify this. This will turn out to be, if I rationalize this, 28 into 6 minus 2 root 2 divided by 6 plus 2 root 2 into 6 minus 2 root 2, which is going to be 6 square minus 2 root 2 whole square. That is 36 minus 8, which is 28, which will cancel out. So I have a plus b is equal to 6 plus 2 root 2, and I have a minus b is equal to 6 minus 2 root 2, which means that a is equal to 6 and b is equal to 2 root 2. So now I have 5x plus 14 under root is equal to 6, which means 5x plus 14 is equal to 6 square, that is 36. Or I have 5x is equal to 22, or 10x is equal to 44. So I have to find root of 44 plus 14, that is going to be root of 58. So our answer for question number 20 is going to be option B. So again, this is a trick question. Squaring feels like the natural thing to do, but do consider that the other side also has an irrational term. So it's going to be difficult to square. All right, moving on. Find the sum of the series. Again, I think I've said this many times in this session. You are adding fractions. I can't add fractions if the denominators are not same. So either I should be able to make the denominators same, or these individual terms can be expressed as differences, which I can then leverage, by cancelling terms out. However, I see that everything is 9. So this is what? Log 3 base 9 plus log 9 base 9 plus log 27 base 9. So, 1 by log a base b is actually equal to log b base a. So this is going on till log of 3 to the power n base 9. So first of all, I'll convert this into 3. So I'll get 1 by 2 in front of each term, which I will take common. So my question becomes log of 3 into 3 square into 3 cube till 3 to the power n to the base 3. This is going to be 3 to the power 1 plus 2 plus 3, which is going to till n. And I know that the sum of first n natural numbers is n into n plus 1 by 2. So this is 1 by 2 into log of 3, log base 3, 3 to the power n into n plus 1 by 2. So this, if I bring down, this will become 1, and your answer will turn out to be n into n plus 1 divided by 4, which is option number D. Final question. You have log x base 2 plus log 2 base x is equal to 10 by 3. You also have log y base 2 plus log 2 base by is equal to 10 by 3. If I, and this is a very, again, a very common sort of pattern, if you identify, it's going to be very helpful. Uh, if I write this as log z base 2 plus log 2 base z is equal to 10 by 3, and if I say this is your a function in z, what would be the roots of this function? X and y. So let's convert this into a quadratic. Let's say this is log z by log 2 plus log 2 by log z is equal to 10 by 3, which is going to be log of z square plus log of 2 square minus 10 by 3 times log z into log of 2 is equal to 0. The solutions to this are, log x and log y. Now I am being asked x into y, which means I need to find log x plus log y, because this is going to be log of xy. So what is sum of the roots of this quadratic? Minus b by a, which is 10 by 3. So your answer will be 2 to the power 10 by 3. This is your log xy.